So in experiment 31, we're going to actually do a redox titration. And in this redox titration, we're going to use potassium permanganate to find out the amount of iron in a sample. So we'll have an unknown sample that has a certain amount of iron in it with other inert materials. And we're going to use titration to figure out the amount of iron in that sample. Now, potassium permanganate is a very, very strong oxidizing agent. So please, if you do this experiment in person, don't get it on you. And you'll see as I do this, I'll wear gloves, I'll use a lot of protection. Although it's very pretty, it's very, very strong in terms of it will burn holes in your clothes, it'll burn holes on all kinds of interesting things. The molarity that we're using of this potassium permanganate is only 0.02 molar, and you will need that for the calculations. Now, as I said, this is a redox titration, and remember, in redox chemistry, one species loses electrons, another one gains them. And so the overall balance equation for this reaction is given above, and you'll notice that you go from an iron plus 2 to an iron plus 3. You have to actually change that. And so in order to go from +2 to +3, what did you do? Did you gain an electron or lose an electron? You actually lost an electron. And when you lose electrons, that's the species that's being oxidized. The permanganate ion is what's being reduced. Okay? And so remember, to be an oxidizing agent means that you are the species that's reduced. Okay? And so this reaction is what occurs. Now, permanganate itself, as I said, is purple. The iron solution is clear. So the way that we know that we've reached the end point in this titration is the solution actually turns pink. And the reason the solution will turn pink is when there's no more iron left, then we get excess permanganate ion that shows up in solution, and that's actually what the indicator is. It's the excess permanganate ion. So we'll move over and we'll do the experiment. Very easy titration, just you have to be cautious of all your safety materials. So we weighed out our sample that contains some iron and some other materials, and the mass of our sample is 1.5011 grams. We're going to transfer that to our Erlenmeyer flask, and then we're to add 50 milliliters of 1 molar sulfuric acid and begin titrating immediately. Once we add 10 milliliters of that titrant, we're then going to add our concentrated phosphoric acid. The reason for this is it does make the endpoint a little bit sharper, and so we'll add this. We're supposed to make sure everything dissolves first before we begin titrating. So swirl, swirl, swirl. And now that the sample is done, we start adding. I'm starting at 0.00 milliliters of permanganate. Now, permanganate's hard to read on the burette, so I'm going to read the top part of the meniscus instead of the bottom. And so we add this, and we go going down to 10, and this is where it gets a little tricky, because we've got to be able to see that we're at 10. That's 6, 7, 8, 9, and we're at 10 there. So now, after 10 milliliters, notice how it's a little bit yellow. By adding this, it'll make it a sharper color change. So we add this, and we keep titrating until we see that pink color persist. And it's slowly, slowly going away. It's almost there. See how it takes longer for it to go away? And there we have a nice pink color. And our final burette reading is reading the top part of the meniscus. We are at 19.90. So 19.90 milliliters is our final volume. So we ran the final 2 trials of this, and in the second trial, our iron sample was 1.5101 grams. Our initial burette reading was 0.00 milliliters, and our final burette reading was 20.12 milliliters. In trial number 3, we weighed out 1.4991 grams, and our initial burette reading was 0.01 milliliters, and our final burette reading was 19.50 milliliters. So with this information, you should be able to determine the amount of iron in the original sample.